2,000 years ago, when most civilizations still struggled to build simple walls or wooden bridges, the Romans were doing something entirely different. They were reshaping the very face of the earth. From cutting through mountains with primitive tools to raising colossal amphitheaters, in a few short years, Roman engineers achieved what should have been impossible. And the most astonishing part is that many of their creations, roads, aqueducts, ports, fortresses, still work today. Not because of magic, but because Rome perfected something far more powerful, a universal engineering system. Most people imagine Rome's greatness coming from its armies, but behind every legion was an invisible force even more important: the engineers who standardized construction across the empire. While Greek builders sought to create unique masterpieces, the Romans pursued something else entirely: absolute repeatability. They didn't want one perfect bridge. They wanted a bridge they could build 100 times with predictable results. They didn't want a beautiful city plan. They wanted a template, one they could replicate from Britain to Syria. This philosophy changed everything. It allowed the Romans to build astonishingly fast. When the legions arrived at a new province, they did not debate how to design a city. They already had the blueprint: a rectangular grid, a forum in the center, bathhouses, a temple, barracks, defenses, and perfectly measured streets. The moment construction began, the land was no longer wilderness. It was Rome. Even the tools were standardized. Engineers in distant provinces used the same measuring rods, the same weights, the same manuals, and the same terminology. A Roman engineer trained in Alexandria could instantly take command of a construction site in Gaul, because everything, from brick sizes to water channel gradients, was identical. This allowed the empire to coordinate tens of thousands of workers, soldiers, and craftsmen with military precision. But Rome's greatest engineering weapon wasn't steel or stone. It was people. Legionaries were not only warriors, they were builders. Every soldier carried tools: a pickaxe, stakes for fortifications, saws, and baskets for earth. On campaign, legions built bridges, roads, trenches, fortresses, and siege ramps with unbelievable speed. This wasn't a special operation. It was daily routine. Each evening, even after long marches, legions constructed a fortified camp in a matter of hours. Scouts surveyed the land. Engineers marked a perfect rectangular layout with colored stakes. Soldiers dug moats, raised ramparts, drove stakes into the walls, and arranged tents into perfectly aligned streets. Every camp, whether built for one night or 1 month, followed the same plan. This system turned Rome's army into something the ancient world had never seen: a mobile construction corporation with military discipline. But the true revolution came from a material that changed history forever: Roman concrete. Harder, stronger, and more durable than its modern equivalent, Roman concrete could even harden underwater. This allowed the Romans to build harbors, piers, docks, and aqueduct foundations where no other civilization could. The secret ingredient, volcanic ash, called pozzolana, triggered chemical reactions that made the material self-repairing. Over time, cracks healed themselves as new minerals formed, making the structure stronger instead of weaker. This alone explains why Roman ports remain intact after 2,000 years, while modern concrete crumbles in decades. With concrete, Rome broke free from the limitations of stone. They could sculpt space, curving walls, soaring vaults, enormous domes. The Pantheon, the world's largest unreinforced concrete dome, still stands untouched. To this day, engineers debate how such precision was possible with the tools of antiquity. One of the most extraordinary achievements of Roman engineering was the road network, an estimated 400,000 kilometers of routes, with 80,000 paved in stone. These were not ordinary roads. They were military arteries designed for speed. A Roman engineer's goal was simple: draw the shortest line between point A and point B and build it, no matter what stood in the way. If a hill blocked the path, they carved a pass. If a mountain stood in the way, they built a tunnel. If a swamp threatened progress, they drained it with wooden piles or constructed raised causeways. Their obsession with straightness wasn't just engineering, it was ideology. A straight Roman road cutting through wilderness declared, "Rome has arrived, and nature will obey." Surveying required incredible precision. Using simple tools like the groma, chorobates, and dioptra, engineers measured gradients and angles with near-modern accuracy. Then the legions set to work. First, trenches were dug and filled with large statumen stones. Above that came layers of compacted gravel, crushed brick, and fine sand-lime mixtures. Finally, massive stone slabs were fitted so tightly that even grass cannot grow between them. The convex shape allowed water to drain into ditches along the sides. Some foundations were over a meter deep, which is why many Roman roads still serve as the base for modern highways. But the roads were only the beginning. Aqueducts delivered clean water to cities through enormous stone channels that stretched tens of kilometers. Over 90% of their length ran underground, safe from damage and evaporation. Only when a valley needed crossing did the Romans build the majestic arched aqueducts we admire today. Gravity was their engine, a precisely calculated slope of just a few centimeters per 100 meters kept water flowing smoothly. Roman engineers even understood hydraulic pressure well enough to build inverted siphons, systems of lead or stone pipes that forced water down one side of a valley and up the other using pressure alone. This required advanced knowledge of physics far ahead of its time. Inside cities, aqueduct water fed fountains, baths, latrines, and even homes of the wealthy. Clean water and sanitation allowed Roman cities to thrive like no others in the ancient world. Then came the amphitheaters, the most spectacular proof of Rome's construction speed. The Colosseum was built in under 10 years, an almost impossible achievement for a structure seating 50,000 people. Its speed came from modular design. The amphitheater consisted of repeating arches and vaults cast in concrete. Multiple crews could work simultaneously on different sections. Cranes, powered by human treadmill wheels, lifted stone blocks weighing tons. Logistics operated like a well-oiled machine. Quarries supplying travertine, barges transporting cement ingredients, and thousands of workers divided into specialist teams. But the Romans didn't build monumental structures just to impress. Everything had a purpose. Roads moved legions, aqueducts supplied life, fortresses secured borders, amphitheaters unified people under Roman culture. Infrastructure itself became an instrument of imperial power. What makes Rome's engineering legacy truly astonishing is not just what they built, but how long it has survived. Modern construction often prioritizes speed over longevity, but Rome achieved both. Their foundations were excessively deep, their walls far thicker than necessary, their roadbeds meticulously layered. Quality was not an option, it was policy. Yet the secret wasn't simply superior materials. It was Rome's understanding of physics, water, weight distribution, and long-term decay. They mastered the arch, not just as decoration, but as a compression structure that could support immense loads. They implemented drainage systems everywhere. They built roads that shed water quickly, bridges that resisted floods, and concrete that strengthened in seawater. Even their temporary marching camps were engineered with geometric precision. Many remain visible from satellites, perfectly rectangular outlines untouched by time. But their greatest innovation wasn't a structure, it was an approach, a system of engineering education, manuals, standardized tools, logistics, and workforce organization. This was the birth of engineering as a profession. Vitruvius wrote detailed architectural treatises. Surveyors, masons, blacksmiths, sawyers, and crane operators worked in coordinated harmony. Every worker knew his role. Every tool had its standard. Every design had its template. This system meant Rome could mobilize thousands of men to build an entire fortress in days, a road in weeks, a city in months. No civilization before or since has matched the combination of speed, scale, and longevity. When we walk today under the arches of the Pont du Gard, when we drive on highways built atop Roman foundations, or when we marvel at the Pantheon's dome still standing untouched, we are not just seeing ancient ruins. We are seeing proof of an empire that built with eternity in mind. Rome conquered through engineering as much as through war. Their roads carried armies, but also language, culture, law, and ideas. Their aqueducts brought sanitation that prolonged life. Their concrete created architectural possibilities no one had imagined. And their legacy challenges us with a question. If ancient engineers with simple tools built structures that have survived 2 millennia, why do many modern buildings crumble in decades? The Romans didn't build for themselves, they built for the world that would come after. And that is why their engineering, fast, standardized, powerful, and eternal, remains one of humanity's greatest achievements.